To start off, I'd like you guys to imagine the scene where you just hiked up to the top of a mountain or a high hill, and you want to come down it, right? Well, sometimes that can be kind of a hard task to come down a mountain, right? So we have these things called ziplines. Ziplines are a fun invention that engineers have created to allow us to travel at very fast speeds down a mountain or a higher elevation. And this is an example of zipline in Labidi Haiti. That was really fun, right? Well, this person got up to almost 45 miles an hour. That's pretty fast, isn't it? You can go faster than that, as fast as that in a car. And this is one of the many lines can provide for us. My name is Brandon Vogel. I'm a biological system engineering major at the University of Nebraska. And today I'm going to talk to you guys about ziplines. What makes ziplines fun? Well, ziplines, in fact, allow you to travel at really fast speeds. I mean, that one video alone, the person was going at 44 miles an hour. That was the top speed I saw. Now that's really crazy to think about, that you can be going that fast just on some in a harness and on steel wire. And you can also travel from really high elevations. Today I'm going to talk to you guys about the design, the physics and engineering principles all behind the creation of ziplines. First, I'm going to talk to you guys about the design of ziplines. There are two anchoring points that are needed to hold the zipline together. And you need to have the front end and the back end so that the zipline can be anchored firm and to make sure that it is good to go. And also, there's many other different things that go into the creation of a zipline, and I will get to those further on in this presentation. First off, that is the bolt and screw that is needed to hold the end of the zipline that allows for it to stay standing and structured so it doesn't move while a person is moving along it. Brakes are a very important aspect of ziplines because when you're going down really fast at 45 miles an hour, you gotta have some way to brake, right? Well, there's many different mechanisms that people have used for brakes. You can use a leather glove to hold on tightly to the top of the steel wire, and this is kind of like a more old-fashioned way of stopping the zipline. There's also a bungee brake where you can pull on a cord that will, or two cords that will release and cause the brake to engage and causing the zipline to break. And the block brake, it's kind of behind my picture, but the block brake is used to make sure that it engages the brake so that it stops immediately. The cable is typically made of steel, which is a very strong structure, so it's not going anywhere, which is very important because if we're sending people or very important items down a zipline, it's very important to make sure that the cable is very secure. Typically, these are very thick. If you've ever seen like a construction rod, it kind of resembles this for like a really thick steel cable to make sure that the humans are safe when operating zip lines and make sure that everything is anchored and secure at certain points. Pulley is a very important aspect for zip lines. It's what allow people to go down a zip line or send objects down a zip line. And typically they are used to there's typically one or two pulleys that are used with either a harness or, in this image, like handlebars that people hold onto or are locked into that go smoothly down the steel wire that I talked about earlier and allow for pulleys to go will allow the cable to go through the pulleys quickly and rapidly and work as a simple machine to glide down the zip line. And this is the Jebel Jais flight. It is very, very long, and it's actually, in fact, almost 20 football fields long. And this is in Puerto Rico, and I'm going to talk to you guys about how long is 1.76 miles long. It's very long, isn't it? That's kind of crazy that you could travel on a zip line for that long. And see there, the person is in a harness, and it's very important to make sure that they're safe when going down this. That is the equivalent of 28 football fields long. 28 football fields. I said 20 earlier. It's actually 28. That is way more than. I mean, that's just imagine 28 memorial stadiums back to back to back to back. That's how long this zip line is. So we talked about the design process that goes into the creation of zip lines, and next we're going to talk about the physics of zip lines. Zip lines use forces acting on them. There's a lot of different forces that are involved in zip lines. So you have the tension force, which is the force of the two cables that are holding you to the tree or like post on either ends of the zip line. And then you have gravity, which pulls you down, which allows the pulleys to be able to go down. You would go through the pulleys and go down the zip line, because typically the zip line is not a straight line, because if it was a straight line, you wouldn't move, because gravity is the force that pulls you down. And then there's also friction force that work against gravity and the tension force and in the pulleys, so that you do not go down like you're falling like gravity. You're just gravity is acting on you at a slower rate than it would be if you were like skydiving, for instance. There's forces of gravity, tension, and friction, and that all act on zip lines. There's also potential energy, which is the amount of energy you have initially at like a really high point, and then kinetic energy, which is how fast you are going, which is the amount of energy you have for how fast you're moving. For this, as you can see on this right side, that the potential energy is very high at the top of the zip line, and the kinetic energy is non-existent because you're not moving. However, when you get down to the bottom of the zip line, your kinetic energy is now all converted to potential energy because you're no longer moving. But when you're at the middle of the zip line, your kinetic energy is really high because you are moving at the fastest rate you can go. Remember, we saw at the beginning of the video that the person was going 45 miles an hour and then it's kind of slowed down a little bit as it reached the bottom of the zip line? Well, that's kind of like this case, where you have really high kinetic energy at the middle, where the person was going 45 miles an hour down the zip line, but then eventually he came to a halt at the end of it. And that's what potential and kinetic energy are all about. Kinetic energy works when you are moving, and potential energy is for how high up you are when you are moving. Energy A at point A and point B and point C are all the same. And the law of conservation of energy, I don't know if you guys have learned about this, but essentially it means that the energy cannot be created nor destroyed. It can only be changed forms. You transfer from potential energy at point A to all kinetic energy at point B, and then back to potential energy at point C. And these all have the same amount of energy at each level. So we talked about the design physics about zip lines, and now we're going to talk about engineering about zip lines. Engineers improve the health, happiness, and safety of the world. Mechanical engineers work to install and make sure that all the inner working of mechanisms. So we talked about the brakes and the pulleys and all the other simple machines that all go into creating a zip line, and mechanical engineers work to make sure that all those are working properly. Mostly they work to make sure that the pulleys are working properly as well as the brake system. Materials engineers, on the other hand, work to They work to make sure that all the materials that are used in the zipline, such as the steel wiring, as well as the brake system, and the pulleys and the harnesses, all have correct, adequate materials to keep humans safe, as well as all different objects that can be transported down ziplines safe. Structural engineers work to make sure that the structures on either end of the zipline are safe and secure so that they do not fall down when someone is going down the zipline. Typically, these are strong steel structures that are built up. Buildings or even trees are different examples of how ziplines have been created and attached to them. And construction engineers work to make sure that the overall process and construction of the zipline is created well, and there's no issues that are ran into while creating a zipline. Engineers are working to make ziplines fun, safe, and exciting. Thank you for listening to this presentation. Please let me know if you have any questions.